Hi folks, we're going to take a look at page 42, number 46 on the course review. So they want us to find the point or points of intersection between these two functions here, so both logarithmic functions. Okay, so in order to do that, we're going to equate the two y values since we're looking for points of intersection, so the x's and y's are assumed to be the same. So let's equate these two. So we end up with this equation, log x equals 1/2 log of x plus 1, that we have to solve for x. Okay, so I suppose the most direct thing to do, at some point we're going to want to bring together these two logarithmic expressions, but we're going to have to bring up the 1/2 using the ski-slope rule so that we can apply one of the other log laws. Now, the only issue here is that when I bring up this exponent, it ends up being exponent 1/2. So it's going to be treated as a square root. And that's perfectly fine. And I'm actually going to show you how to do that um, in that way there. But just a good trick here is why don't you just multiply both sides of the equation by 2? So that instead of having a coefficient of 1/2 in front of one of the functions, you're going to have a coefficient of 2. So when I use the ski-slope rule, I'm going to have a square, which is usually nicer to deal with. So that's how I'm going to do it first off. So I'll multiply both sides by 2, so I end up with 2 log x equals log of x plus 1. Okay, and now I'm going to bring everything to one side of the equation so that I can bring together these two logarithmic expressions. So while I'm at it, I'll use the ski-slope rule to bring up the coefficient of 2 and make it log of x squared, and then minus log of x plus 1 equal to 0. And now, because I've just have two logarithmic expressions, I can use the second logarithm law to bring these together. So this becomes log of x squared over x plus 1 equals 0. And I have the format that I'm looking for, which is a single logarithmic expression equal to a number. So I'm now going to convert this to exponential form. So we have x squared over x plus 1. The result is equal to the base of 10 to the exponent of 0. So 10 to the 0, which of course is just 1. And now I have a fairly simple rational equation to solve. So since it's an equation, there's no problem with multiplying both sides by the denominator. So I'm just going to multiply both sides by x plus 1. So I end up with x squared equals x plus 1. And I just have a nice quadratic function, a quadratic equation to solve. Okay, now unfortunately this doesn't factor nicely, so I just have to use the quadratic formula. So x is equal to negative b, so 1 plus or minus square root of b squared, which is 1, minus 4 times a, which is 1, times negative 1. So 4 times negative 1 is negative 4. And so we just have that x is equal to 1 plus or minus root 5 over 2. Okay, now this is where we have to be careful because this is the solution to this quadratic equation, but of course what I'm trying to solve is the original logarithmic equation. And I can see here I have log x and also log of x plus 1, but anything that's negative is going to be an issue. Okay, and I see here, I don't know exactly what root 5 is, but it's definitely bigger than 1. So 1 minus root 5 is going to be negative. So I'm actually going to eliminate that one there. So my only answer that I'm going to accept is 1 plus root 5 over 2. Okay, so there's the x value of my point of intersection. So if I want the y value, I just have to stick it into one of these two functions. And of course, I'm going to choose to stick it into log of x. So my point of intersection here is just my x value is 1 plus root 5 over 2. And my y value is log of 1 plus root 5 over 2. And I'm going to leave it like this so that I leave it as an exact answer. So there's my point of intersection. Okay, so this is, a fairly straightforward logarithmic equation to solve. The only thing we did to make our lives a little simpler is to multiply both sides by 2 so that I didn't end up with this fraction, which eventually was going to become my exponent when I use the ski-slope rule. But just to show you that I can do it this way, okay, I can solve it this way here. Just bring everything to one side. So we have log of x minus, and I'll bring this 1/2 to the top. So log of x plus 1 to the 1/2 equals 0. use the second logarithm law. So this becomes log of x over, and of course x plus 1 to the 1/2 is just square root of x plus 1 equals 0. And now again, very similar to what we had before, single logarithmic expression equal to a number. So we have x over root x plus 1 equals 10 to the 0, which is 1. And now this might look complicated, but let's start by getting rid of this denominator. So multiply both sides by root x plus 1. Okay, and how do I solve this? Well, I need to get rid of this square root, and I can do that easily by just squaring both sides of the equation. And look what I end up with. X squared equals x plus 1, which looks exactly like what I ended up with in the previous method. Okay, so all the other steps would be exactly the same. So it would have been perfectly fine to solve this equation working with the exponent of 1/2. It's just, I suppose, a little more familiar um, to not have to work with the square root, to work with a square instead. Okay, so that's it for this one.